Hello. I'm back. So, let's take a look back here. One thing we should probably do is get the attribution for some of these assets I've gotten. So we'll go down to the README with game engine. Say Minesweeper. Cool. So now we want to see if we can get away with a different 9 patch here. And maybe even distort it differently. So we'll look for the 9 patch that we have. Excuse me. So we want a destination edge. I think that's the same as the other destination edges. Yeah, that looks a lot cleaner. But before we do that, let's just see what number this starts to look bad at. Just zoom in. You can already see that it's kind of getting clipped. So we'll bring it up to 11. Still clipped. 12. Clipped. 15. It's a little clipped. 14. Let's just try 20. What happens? There's like no difference almost. Go back to 15. It's a little cleaner. One thing that we can consider doing is just opening the image in GIMP and just seeing where the corner is. So reveal in Finder, bring GIMP back up. I'll zoom in. Scroll over. Which was a little bit more obvious. Go to 11 by 11. Let's go here. Okay, 11 by 11. See if we can. Just see if we can make out the alpha value. I'm trying to figure out which one is alpha. Is RGBA. What if we did 15? 15. These are all 0. Okay, we'll just stick. If it's still 0, then that's the one we want. So we'll do 14. Those are all 0s. So we'll do 13 now. That's still 0. So we'll do 12. Still 0. So we'll do 11. Okay, 11 is what we have color, so we'll go back to 12. Just the middle. so 12 is what we want. So we'll go back to Minesweeper, say that this is 12, and say that this is destination edge. Reset the view and refresh, and this looks a lot cleaner now. And the goal is kind of to like match the thickness of this border too, and I think it just about does it. Let's look at the README again. So we have the Minesweeper, we have the button, we have the explosion. Cool. I don't think there's much more that we learned from Minesweeper, to be perfectly honest. And so the next game I'm thinking of doing is Solitaire, which will pretty much use a lot of the mechanics we already have in place. Excuse me. Alright, so let's make it easier to like navigate to different games and whatnot. So we're gonna create, this will be, we'll call this index. It should just be a link to all the games. And we'll call this const game, which is a function, the name of the game. This could be essentially the exact same code too. String, and here is going to be CID string. We'll do const games equals an array name Minesweeper. Slut Minesweeper. And so in here, the body, we can get rid of that, get rid of that. And what we're going to do is, we're going to do a UL li. Actually, we're going to do games dot map game li. Okay. Game dot name href equals game dot name. Get rid of this. We'll go over to here and say this is index. Here we'll say if row dot slice from 1. Just the const game equals slut. Excuse me. Dot path name. basically return a new response, index, headers. It's the same. Except it's not gonna be index, it's gonna be game. Well, this index response, game response. So in here we'll do game equals games.find game whose game.slug equals game slug. And so in here we'll say game response, game, go to game response, and here we'll do an h1 that says game.name, and here will be game.slug. And here the game, we'll say game here, and we'll say like game equals, it's going to be an interface actually. Name is a string, slug is a string. Let's see. And then each of these should have like a go home link. Do a refresh. Can't find variable index. Understandable since it doesn't exist. Cool. And we'll take away the body padding for the index. In here should be slug. Do a refresh, click on it. So that brings us to the Minesweeper, that brings us back. And we die instantly. Perfect. So I'm gonna take the to-dos and move them to the README. Let me just minimize this. Say Solitaire, because we want to create the functionality of dragging and dropping. So let's add that here. Do this so that we properly refresh the server. We'll create a new file called Solitaire TS. And we'll say start. Let's close this. Care.state. And then the start comes from the engine. And we'll have to go to types. Let's try to move things out of the engine if it doesn't belong here. They might all belong here, but it doesn't hurt to check. We don't want to use bounds. Okay. Export namespace solitaire. Export interface state extends global state engine dot global state, that is. I'll have to go over to, yeah, let's go to index. Let's take this out of here. I'll just make it global. Go back to index, tell it about that type. Cool. And then we'll add that new game. Solitaire. Solitaire. Let's move this up here. Do a refresh. Need to do a join on the empty string so we don't get that comma. Go to solitaire, and we do get an error. So go to solitaire, import this, and we'll say dot 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 default state. Drawables is empty array. Height is just put 600 for now. State is just empty object. Width is just put 600 for now. Debug, we'll just say debug is true. This needs to go here. Do a refresh, and we got our 600 by 600. We're not clearing this screen, which is important. We should do that. All right, so I think like the main thing that Solitaire is known for is the background. And I wonder if that should be part of the renderable. So we go here, go to engine with optionals, and then let's rename this to config with optionals. Go to config. And when my config take background, and then in the engine, when we start, at some point we call render. When we render, before we draw anything, we want to context.fill rect 0 0 context.canvas.width context.canvas.height. And then we say context.fill style equals render.background bubble.background. And so now we can go into Solitaire. make this where is it? Background is going to be optional always. So when we go to the engine, go to the background, I'm going to say that it's black. Yeah, black. Go to Solitaire, and now we can say that the background is green. We refresh, we see the green. All right, so let's find some assets for the game. I kind of want it to be one giant asset. I think that would be ideal. Downloads, free, unzip. Okay, this is an option. Just leave it open on the side. If it's a zip, it's probably not going to be any good, to be honest. Or at least it's not going to be what I want. Playing cards. This one I think is higher quality. Does it have a back? I think having a back's pretty important. It has jokers, but it doesn't have backs, which is no good. Oh, not this one. Alright. Since it's a zip, it still seems highly unlikely that it's the format I want. Cards pack. Did I not download it? Oh. Alright, these are probably the closest. Ooh. Ah, it's a zip. These are actually horrible looking. What? Why does it look like it's written on? That doesn't look good. Alright. I think we're gonna have to go with these ones. Free game assets. I don't think I like the license though. Public demand's way better. Okay. Let's take another look at the image. So cards pack, PNG. Pick the largest one. I'm just checking to see if they use a transparency layer or not. Kind of afraid that they did not. Does seem a little blurry. Alright, well, let's do new folder. Not focused. Minesweeper. Take all these, put them in here, move. We'll go to the Minesweeper file. Find anything that's /public. Let's say Minesweeper. Find another public. Any other publics? Any more publics? There was. Cool. So now we'll make a new folder in public. New folder, Solitaire. Let me update my stream title. Okay, it's updated on YouTube. Give me a moment. Excellent. Save it. We do an edit. Solitaire. Done. Cool. All right. Thank you. All right. So let's go to the Solitaire file. Close others. Go to here. We'll do a refresh, make sure everything's still working. Looks like it is. Oh, another thing that we're gonna need is like a drop zone, but we'll probably figure out an interesting way to do that. For now, let's do a card. We'll do a card by putting those files here first. Take all of these, put them into the Solitaire folder. Oh, I wish they didn't have spaces in their names. Alright, so what I'm thinking is we'll do const hard equals drawable. X will be 0, y will be 0, image will be slash public slash solitaire slash I hate it so much actually. 1.png. And then we'll say drawables part. Just see what happens. Look at the network. Let's take a look, and I gotta imagine that the space is giving us some grief. So what we're gonna have to do is go into the index. I'm trying to do something in here. Do console.log, hero.path name. I'll do a refresh, look at the actual code that's running, and we get a error. Let's put this a little earlier. And it's indeed having some issues. So we're gonna have to do does it decode eerie component? We'll try it. Okay, back to console. No longer getting errors. Perfect. But we're also not drawing, and that's because we don't have a width or a height to draw with. Cool. And we do have debug mode on, so we can turn it off for now so we don't see the red outline. And what we can do here we can take a look at the values. So we'll go to the types, and then we'll start adding stuff to the solitaire. So we'll say export type suit equals spades parts diamond clubs. And we'll say export value. We could do 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. We can also do ace 1, export const jack is 11, export const queen is 12, and export const king is 13. Oh, we'll do this somewhere else. We'll put it here. No need to export. say const card with take a look at the image. 103 by 138. 103 const card height. Height equals 138. And so we'll match that and do card with card height. Cool. So that's just one card. What we want to consider doing is creating a data type. Export interface card data, which will have a suit. It'll have a value. And so what we'll do here is we'll specify that, and then we'll specify solitaire.cardData, and we'll make this return a template string. And it'll be this dot data dot value. Let's see. Go to this. This is no longer optional here. It's optional somewhere else. So we can just not do that. Which makes me wonder if we failed to do that for the Minesweeper data. So we can just do and then delete this BTW. We'll find data dot data. So there shouldn't be any use for that. And then there should be no need for either of these. Cool. All right, I'm happy with that. It's a nice refactor. And here we put this .data.value. And here we do data is suit, which is clubs, and value is 1. Let's do king. And we'll do these as consts. Clubs is clubs. Hearts. Hearts. Diamond. Diamond. And then spades. Spades. And then we can just use the constant here. Cool. So it's drawing the king down, the king of clubs. And And so just to kind of make sure, hello Alpha Technology, the good bun. Yeah, we are using bun. I'm assuming that's what you mean, but I could be wrong. Do const suits equals. This will be an array of suit of solitaire suit. That's not suit, that's state. Clubs, hearts, diamonds, spades. That would be const values equals solitaire dot value. I'll say it's an array. And just for fun, we can just say ace, jack, queen, king, and then we can just create the cards at this point. Cards is complicated. We'll say array dot suits dot for each suit, and we'll do a map, a flat map that is, and then in here we'll do return values dot map value. And here we'll do this code. I don't know, maybe it doesn't need data anymore, but we're gonna keep it anyway. But the image could potentially be simplified. No, because we might want to flip the card over. So we'll just leave that as is. And this will be cards. Oh, we didn't return. And so one thing we want to do is space the cards out by suit. And there's actually a specific order. The order for suits cards. Clubs, diamonds, hearts, spades. Cool. And before we lose track, let's put a link to this repo into our README for Solitaire. Okay. And so we want to use the suit and we want to use the value, that's for sure. And the X is going to be column times card width divided by 2. And the Y is going to be row times card height. We'll try that, see how that looks. Cool. So one other thing, I wanted it to be const card scale 0.75 times 0.75. Sorry, card scale. You see the problem is it's not drawing the entire card now. So let's fix that. We need to go into the engine to do it. I feel like in this case, we're gonna need to know I think we're gonna have to keep these as undefined. And then later on, when we do this, we gotta see if it's x, sy, and sw, and sh. Then we'll do this. Otherwise, we'll do and we just need it to be not undefined, I believe. All right. Let's see if we can get away with writing a function like this. All defined. We're going to have this type T over here. It's going to be an array of T or null or undefined. And what this returns is the fact that input is T. And return true. Does that help us at all? Okay. Number null or undefined. Does it get typed like this? Must be an array type. Are you unhappy? You can't reference a rest parameter? Interesting. Fine. I won't. Number and unknown array. Fine. Is defined. This will be a util function. We have to export that. Go back to the engine, find that function is defined, and import it. Excellent, and then there's this, which is what is missing data. There's a config data exclamation, right? What else? Okay, so hopefully it draws the whole image now. Excellent. I'll turn the debugger back on. Do a refresh. Okay, cool. Alright, so we want to figure out how big the screen's going to be. And to do that, we need to essentially figure out how big the cards are. And so let's look at some inspiration. It's not what I wanted to do. Okay, so there's 1, 2, 3, 4, 5, 6, 7 piles. 4 on top, 2, so, and then another 6 up top. So over here we can say const width. And we're gonna put a gap between each pile. So we're gonna say const pile gap equals 5. We'll just call it padding because we'll just put it everywhere. So the width is gonna be padding on the left between each pile and on the right. And so padding, so if we have 7 piles, there'll be 6 gaps, plus 2 more on the edges, so 8, plus the card width, times 7. That'll be the width. Const height is the top 2 rows pile up, so it'll be card height plus, and then in theory we could fit 13 cards in a pile, but we're only going to use like the top portion of the card. Not too sure how much, but I do want some kind of whole number. So what we got to do is like just consider, and when I say whole number, I mean like divide by 5, divide by 6, something like that. For the second portion, we just need to imagine that we're gonna have 13 cards that are stacked on top of each other, because that's the, well, actually there could be more. How big's the biggest pile? Just assume this image is correct. 1, 2, 3, 4, 5, 6. So it'll be 13 plus 6 times card height times 0.2. And then we'll just use that as the width and height. We'll do a refresh. Okay, it's not unreasonably big. So I'm perfectly fine, perfectly happy with this. I think one more thing we could do here is revealed is false. And we'll do if this dot data dot is revealed, and we'll do that. Otherwise we'll do slash public slash solitaire slash back glue 1.png. Cool. And just for some variety, we'll just make it sort of like if row plus column mod 2, let's say mod 3 equals 0. And then we should go to the types file. Types, where are you? And we'll say is revealed is a boolean. Do a refresh. Okay. So they all have their own individual reveal or hidden states. I've already been going for an hour. Jeez. Okay. So we have all the cards now. Something to think about is like determining where and when to show them. Just try to think of an interesting way to show where they are. Let's start thinking about the state. There's going to be the deck. That's not the word deck. Which I think, yeah, it's going to be card data, an array of it. There's going to be the discard, which is card data. There's going to be the piles, which is going to be a double array of card data. What do they call it? There's names. There's the foundation, which is also a double array of card data. There's the tableau. T-A-B-L-E-A-U. Oh, I'm not gonna hate typing that. We'll call this the stock, which is also a double array. Cool. Alright, so what I would want to do, I'll just make these all empty arrays for now. Alright, and then we want to prioritize like the visuals. Oh, it's my favorite song. Back to haunt me. And we're actually gonna go to index and here we're gonna do div, because I don't want this to be in the same line as the canvas. Cool. And then there's one more. There's one more thing. There's the card you're holding. Yeah. And then there's gonna have to be like some information about, it's only a single array. There's gonna be some information about cards came from, and it'll be like the pile. And the index. Because your hand can go back to any one of these, and since they're both string and then index based, we could easily put the cards that you've taken back, even if it's from the stock, even if it's from the tableau, from the foundation, whatever. So let's start drawing. We'll do that. Maybe we can like group this more intelligently. Pile, index. And that's just where we got it from. And then we have cards. Excellent. Alright, so now that we've done all this, what I would want to do is just say these are false, and just say that this is negative card height, and the X is negative card width. And then we no longer need a row or a column. And so the cards are just showing just barely off screen. And so now I want to make the piles. Let's just theory craft here a little bit. What a pile might look like. We'll put it at padding. The Y is padding. The width is card width. And the height is card height. and then we'll put the pile. Pile gets drawn first. We want it to be drawn first. And then we'll say stroke is white. Radius is 5. And stroke width is 5. None of those do anything yet, but we will make them do something. Let's just make those arguments valid first. 1, 2, 3. It'd be stroke with string, stroke width, which is a number, and finally radius, which is a number. So they're all acceptable now, and we see the red outline. So we have some confidence that something might happen soon. If we go to engine, and I think the stroke will happen. Where do we do background? Do background, then we draw stuff on top, then we'll stroke. I feel like the image should happen after the background. I think that would be ideal. And then the stroke happens last time. Stroke equals get value, drawable, dot stroke, state, drawable, if stroke. And we'll do const stroke width equals get value, drawable dot stroke width, state drawable. So we could say context dot stroke width, line width. All right, we're gonna be consistent. Go to types, look for stroke width, it should be line width. Same here. We will default it to 1. Context.stroke style equals stroke. Context.stroke. And we're actually going to change this to be context.fill. And then what we need to do in here is something where we draw the rounded thing. So we would have to say context.begin path, and then we do the rounded border, which I don't feel like writing that code. Is this really a thing? I don't believe it. Okay, const radius equals get value, drawable dot radius state drawable 0. All right, let's see. Okay, well it is red, which is incorrect. We are at 24 frames per second, so I don't think it's an issue with how we're necessarily doing anything. Did I say red or did I not say anything? I did say something. Ah, I see. Problem is that the context stroke that line width equals 1 has to have happened there. Okay. We can turn off the debug for now, just so we can really make out what's going on here. Okay, so this is basically what a pile would be drawn as. Say this is the deck. That's the word, desk. So there's different kinds of piles. There's piles that stack each card on top of another, and then there's piles that will do a stack from the top to the bottom. We're just gonna try to keep it simple for now. We'll say, let's do a for loop and say that this is the stock. I array.from length is 2.map. We don't care about the first star, but we do care about the index that we're at. And the index will help us to determine the x, which will be index times card width. And then we gotta consider the gap, which will be plus index plus 1 times padding. Oh, let's see if it works. Cool. I didn't dot it. Okay, so it's not giving us enough padding. Oh, it is giving us enough padding. The problem is that the line width is too thick. Let's just make it 2. Okay, and then we need to do const foundation equals array.from length is 4.map. Don't care about that. We do care about the index. And we're just gonna steal this code. Except the x is gonna be, I don't know. I think we do like a little bit of extra code here. And then we do return, we say const offset equals index plus 1. Rather than using index, we'll just use offset. And then we put the foundation in. The length needs to be, the length is 4. Oh, I was just gonna put 4 for now. Cool. Where did I use offset? Did I not use it? Okay. Cool. And then finally, we draw what do we draw? The tableau, which is 7. And for this one, we will use index directly. But this will be 2 times padding plus card height. And let's add the tableau. Alright, so we have a foundation coming along here. Alright, let's commit. Okay, so now we need to deal out the cards. Are there rules? Deal out the cards into 7 columns. The first column on the left has 1 card. 7 columns. The top card of each column is turned face up. The rest of the cards are face down. Yes, there are rules in Solitaire, including how to arrange the cards. Of course, of course I know that. Does it really matter? I don't think it matters how you deal out the cards, if it's all just random. And so I feel like we just need something, some kind of like agent that moves the cards around, or at least helps the cards to move around. We're also going to need to know who was the last clicked. Okay, so let's try to get the cards to show up in the right places. Alright, so So whenever you take a card from the deck, it'll go to the discard, to the top of the discard. So what I'm thinking is, let's have a function, const restart. I will call this restart. And restart will take a state, a solitaire state, and it'll do stuff. Most notably, it'll return a state. What I'm thinking is we'll do state.foundation empty array array.from list length. The foundation has 4.map. We'll do the same thing for everything else. The foundation, the tableau is 7. And the stock is 2. And just for safety, we'll say state.hand.card, just an empty array, state.hand.index equals -1, state.hand. Pile is empty string. And it's just a classic card resetting. So the first pile gets how many upside down? None. All right. I feel like is revealed is gonna be part of the state. And so we'll have to figure that out separately. We go to card data. Is revealed will come from the state. So basically this is going to determine where the X and the Y are. So these are the dynamic ones. We'll put them last. Basically, what I'm thinking is we'll do it later. We'll do that later. Just return 0 for now. They should all be here. Yep. And so part of the restart will be creating a new deck. So it'll be const deck. What card data does require. This is card data. Maybe these aren't card data. Maybe these are just cards. Card state. Interface. Is revealed. Is Boolean. A new line there. Go back to Solitaire. The deck is going to be array.from length. Did I do a weird length? No, I didn't. Why am I doing an array from? I could just do suit dot map, flat map. Suit. Excuse me. And then in here we could say value. Except it's not values, is it? It's ranks. Now, we need to go through everything we've written so far. And change value to be rank. Why did I do that? Rename rank. 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 Types is fine, engine is fine, 9 patch is fine. Okay, hopefully there's no more values, just ranks. Ranks dot map rank. It's gonna be rank suit is revealed is false. See what it thinks it is. That's precisely what it is. And the other thing we're going to do is shuffle. Shuffle the deck. This is a function we created for Minesweeper. We use the same function. And so now what we're going to do is we're going to start taking cards and putting them into piles. So we're going to do a for let I equals 0. I is less than state dot tableau dot length I plus plus, and then we'll do for let j equals 0. J is less than state dot tableau. J is less than I. J plus plus. And so for each thing, we're going to just put a card into the pile. And so we'll say state.tableau dot push. State dot no deck dot pop. And then we're going to say top equals this. And we'll say top here. Or we'll say top dot is revealed equals true. Why are you unhappy? Oops. Tableau sub I. Tableau sub I. Okay. So there are cards that are technically speaking revealed in here, but we don't really care yet. What we need to do is const get card, and that's gonna take the state, which is the solitaire state, and the data of the card data, which is solitaire dot card data. And what it's going to give us back is some details. It's going to tell us the pile. It's going to tell us the index. Maybe it should even tell us. It's gotta give us 2 indexes, just in case. So it's gonna be like I almost wonder if it just give the XY, like the base XY, and then the index. We'll give the pile. We'll give the base X. We'll give the base Y. And then we'll give the index. In the pile. And so what we'll do is we'll go state dot. We're gonna do for eaches. State dot. We're gonna look for it in the tableau first. Just got that backwards. We gotta say it const. We say if card dot for const pile of state dot tableau. Pile if card. If card dot rank equals data dot rank and card dot suit equals data dot suit. Then we'll return. We need the index. It's fine, we'll get it some other way. X is 0, Y is 0. Index is 0. Pile is tableau. We won't return null. We'll put it somewhere really obnoxious, like a base X of X's with minus card with Y is height minus card height. Index is 0 and the pile is error. Just do that for now. And so we'll do this. State. We'll say const data equals get card. We'll say card. State this dot data. We can't do that, and we can't do that. And then here we'll return card.x. And then the y is going to be just about the same code. Y. And this will be here. Let's take date as an argument. And we'll say card. Yeah, fine. I have to go to get card. Data dot. Card data, these would be card state, right? I didn't update it. Rank does not exist. Is card dot is revealed. I don't need to do that. What I need to do is revealed boolean. Is revealed true. Okay, cool. So we do have cards that we are not finding on the table, which is good because we have not yet put every card on the table. So in here, we want index. File index equals state.tableau. State.tableau index of file plus card index is file.index of card. We're just gonna be a little lazy right now. The y, since we're on the tableau, is gonna be 2 times gap plus card height. The x is gonna be gap pile index plus 1 times padding. It's not gap, it's padding. I plus pile index times card width. Let's just see what it looks like. Okay. And in this particular case, for the tab, what are we writing this for? I thought we were writing it for the tableau. I guess we're technically writing it for all of them. If card dot you know what? We could just do the math here. The y gets offset it based on the card index times card height times int2. Alright, it's looking incredible right now. Apparently, there is an issue with the draw order. But before we figure out the draw order issue, what do we want to do? Let's put on the debug state. I just want to see if we're hitting some kind of performance issues. Okay, we're doing 24 right now. Alright, let's go to find error. Let's make the X 0 so I can see the FPS much better. So this should not be revealed. The fact that this is showing isn't. Oh, I bet true. Of course it's not showing. Yeah, of course. Okay, so let's put one card. Here's restart. Let's say const top equals deck.pub. Let's see. Let's think about it. So this top card will go directly to the stock. Sub1 dot push top. Okay. And so that shouldn't show yet. And the reason it shouldn't show is because of reasons. I seriously do have a reason though, because we haven't written the code to get cards from the stock. To do similar stock, and the Y is not going to be upset. Okay, well, it should have shown that time. Let's go to sources. Let's look for the Solitaire. In scripts, let's look for... Do I use Tableau anywhere else? This is Tableau, but it doesn't really matter. I'll look for the string stock. There is no string stock because I just made it. Okay, do we ever go in here? We do go in here. Oh, wow, because I'm putting it in the wrong place. The Y is just padding. There we go. But it should be revealed. I think this is just going to be true. The next aspect is the draw pile. And so in restart, if you say state.stock sub 0 equals deck. I think that's fair. We can actually do this first because it's referenced. And then I don't think we need more code. The stock C. It's going to depend on the pile index. The pile index is 1 that is revealed. Okay. Alright, so that's some major progress right there. The next thing is we're going to have to upset this draw order. I think that'd be really, really impactful. How are we going to do that? We are going to do the following. Make it so that cards have a Z based on state. And we return card.index. That's the best idea I have right now. And so in order to implement that idea, we need to go to types, we need to find X. Not that one. And RZ, which is optional. And in the engine, when we draw all, first we're going to do drawables dot map. We want to try to calculate the Z of each drawable. Drawable map. That's what we'll do. Const z map equals drawable dot reduce z map drawable return drawable, const, no, zmap is going to be a record of string to number, and in here we're going to say zmap sub drawable dot id equals get value of the drawable, drawable dot c state drawable return ZMap. Drawballs. And you're unhappy. Because we need to say this is a 0 by default. Now we can do drawables.sort A, B. And we want it in order of smallest c to biggest c. So we'll do a or zmap sub a dot id minus zmap b dot id. We'll zero it out. Okay, now we got the correct draw order. Let's commit it. Excellent. We can delete this empty line. That's fine. What's there? Okay, good to know. I don't know what that does exactly. Good to know. And the important part is we're still at 24 frames per second, even though we're running a pretty major sort function at a certain point. Okay, so I think the easiest thing right now to do is to make it so that the clicking the deck cycles the cards. Yeah, I think that'll be easiest. So basically, we'll have an on click. State and this return state. And what this does, const top equals state dot stock. Yep. State dot stock sub 0 dot pop. Right? If top else. So if there is something on the top of the deck, then we'll just say state dot stock dot sub 1 dot push top. Otherwise, we need to like reset. Is there a really quick way to reverse an array? There is no reverse function, is there? State dot stock sub 0 equals state dot stock sub 1 dot reverse. State dot stock sub 1 equals empty array. Alright, let's just see if it works. Cool. So we want to go into the engine and on click. Oh, we do prevent default. Why is it highlighting then? Should I do event.stop propagation? And then do that here. And refresh. Double clicking this highlights text. Canvas.on select start. Event default event.stop propagation return false. Just be overly verbose in hopes that it fixes this issue. That's not really an issue, but I don't want it to happen. Okay. All right, let's think a little bit now. Is this possibly the worst hand ever? Let's commit it. We can now cycle cards. Excuse me. Alright, we're using 0.2 here. We should probably mention that somewhere. Card peak is 0.2. Card peak 0.2. Card peak. Any more 0.2s? Where you at? Alright, that's everyone. Alright, why are you unhappy? Okay, and we're hitting the 24 frames, even though we have probably the worst algorithm. Alright, so let's think a little bit here. We want to add the ability to drag, pick things up and drag them. We currently don't care about dropping at the moment. We want to be able to drag one or more cards. At the moment, we can only drag one card. If we can at least get that, maybe we can figure out how to expand to 2. Alright, so what I'm thinking is we need to go to types, and where we have on click, we're going to have on mouse down. And when we go to Solitaire, we're gonna first handle the stock. And so we want to figure out const card equals get card state this dot data, or return state. And in the engine, on mouse down, we gotta do one of these, pretty much all of this. And this is gonna be mouse down. And then we're gonna go to here, create a new signal. That's not right. CID, mouse down signal, mouse down signal. And we're gonna just not have these, since we already have that data somewhere else. Go back to the engine, remove these like I said. Go back down to here. This is gonna be CIW state.mouse. We have to have it somewhere, right? Mouse.x. Mouse. 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 Alright, and then we're gonna do it all over again. Do we need to do all of this? There's no way. We don't need to do all of it. We just say drawable dot is mouse and bounds. We've already done the check. C drawable dot is mouse and bounds. Okay, and then we're going to take all of this and paste it, and CID mouse down, mouse down, mouse down. Cool. And we're missing something. There we go. So the idea here being we'll log the last card that was clicked if it is revealed. And that'll tell us which card we pick up. And so if we do a refresh, we click on this card, we get an error. Cool. Alright, let's put a pause. Let's click on the jack. Okay, we don't get an error. Do we get a console? Who do we add this to? We added it to stock, so yeah, of course nothing happens. Data. Alright, let's step out for a moment. So state This is this. The data is undefined. Yes. Since this is the I shouldn't be here. I should be here. Sorry about that. Alright, well, it thinks it's in the tableau. That's also wrong. I have to say if index is 0, let me do all of this. Refresh. Okay, let's log a little bit more just to make sure we're doing this correctly. This.data. I'll do a refresh. It is a spade of 2. This club is 6. Jack of clubs. 9 of clubs. Jack of spades. Okay, cool. Alright, so the idea should be put that card and every card under it, over it, in your hand. That's the goal right now. Alright, let's make sure this still works. It does. Okay, some good progress. What have we done recently? So we optimized clicking and detected mouse down. Excellent. So at this point, we want to basically want the hand to follow the mouse. So it's probably going to be kind of janky looking, but what I'm thinking is, excuse me, I don't know what I'm thinking right now. Time set. What's next? How can I pick up? How can I pick it up? I think that it might like instantly shoot to where my mouse is, like centered. That's what I'm thinking at the moment. With that, the card I grabbed and every card under it will just shoot to the middle. I wonder if, like, as you leave the screen, I should trigger a mouse down event or a mouse up event. That'd probably be pretty important for making this feel pretty clean. Alright, so we need to be able to get cards out of your hands, so for const pile of state.hand for const card of pile. What's wrong? No, not cards. It is a pile, but it's a card. We're basically taking all of this. There's no more pile index. I don't even know why I was allowed to have a pile index. What's pile is it referencing? You could do that? Okay, it's weird. So the X is going to be state.mouse.location.x minus width divided by 2. Divided by 2. Card width. Center it. The Y is going to be state.mouse.location.y. We're just going to move it up the slightest a bit. It'll be minus card height times card peak. And that'll be divided by 2. Center it along the peaking part. Is revealed is going to be true. And this is going to be hand. And there is a chance that we end up not even using some of this code. Just for testing purposes though, we are going to say const n equals state dot stop sub 0 dot top. And then we'll say state dot hand dot cards dot push hand. I just want to see if the hand follows or not. The hand should be last. Z with How do I draw last? If it was 100. Oh, I put a handle. Why did I put a handle? That's the wrong word. Okay, that works. Alright, so let's stop holding that card. Cool. Yeah, we're making Solitaire. We're working on picking up cards. We can't do it yet. So say on mouse down. So since I want to test the ability, I don't really care about dropping right now, I only care about picking up. So that's what I want to test, the ability to pick cards up. So I'm just going to reveal all the cards for the time being. So in here, at least in the tableau, I'm going to say it's revealed. We probably want the peak to be more than 0.2. Now that I see this, try 0.3. Okay. I kind of want the suit to be to the right, otherwise we have to peak a little bit more. Oh. Now we have to scroll just to fit the Solitaire into our window. We could probably peak slightly less. I think that's acceptable. I think in most cases you can make out what is what. So what I want to do is clear that log, make this bigger. I was gonna click on this and see if I get 4 logs. So I got the heart of clubs. Okay, never mind. Of course it's 2 logs. It's detecting what I've clicked on. So I'm thinking initially this code is going to be really inefficient, but it's fine because it's just a game. This inefficiency will only happen when you mouse down, so it won't be a huge loss. Just so you know, Zuha, in terms of what we have, we just have a deck that cycles. So when I click on this, we go through the whole deck. And when we refresh, it's randomized. Since we're debugging right now, where we have all the cards revealed. Once we're done debugging, we're gonna hide these back rows. We also made it so that we have more of like a proper-ish website so we can navigate to our different games very quickly. Winner. And then when I'm done, I go home, I go to Solitaire, and I can start playing Solitaire. The hope being that, you know, as we keep adding more and more and more games, we're just going to make sure that the previous games that we wrote still work. And it's going to create a nice portfolio for us to demonstrate our game engine, what it's capable of, how to use it. It still scares me though. I think it's especially scary when you're too confident. I'm glad that it's noticeable, my improvements. Alright. The idea here is we should pick up every card in the stack. So if we click on here, it should pick up every card in this stack. And given that we have index 0, it should pick up from index 0 onwards, put that into your hand. That's what I'm thinking. So basically, grab, and we'll say state sub card dot pile dot splice from the index onwards. So it'd be card dot index to the end. So we don't have to put anything. You don't like that? Alright. I gotta start being restrictive. I need to make a new type. Card stats. I don't know. Go back to Solitaire. Export interface card stats. The pile is going to be of certain strings. We're going to say stock. We're going to say tableau. We're going to say foundation. That's all fine. This will be solitaire dot card stats. I'll go back up to here. Hand is another type. Hand. Do you want a length? Is that what you're saying? Well, we'll just put this one extra rule. Card dot pile is not equal to hand. And then we'll say state dot hand dot cars equals grabbed. What we need to do here is also card dot pile index and then we need to go to types and say pile index is a number. back down to here. Now we're gonna rename this to card index. And we'll say pile index. Don't double say the name. Pile index. One more. Pile index. Go back to types and say that it's card index. This case, just say 0. Say card index, pile index 0. We'll say this is a type. Fine. Nah, I don't know. Just means we have to add another condition. Card index. We gotta make sure the cards in the hand also draw in the correct order. Oh. And card.pile is not equal to error. This is card index. Okay. I don't know, let's see. Yeah. That is because when I get the hand, the Y should offset by card height times card peak times in card index. Okay. Didn't work. What about this? Oh, okay, never mind. I thought that I had picked up. Okay, I am picking up everything, which is expected at the moment. I should be able to just pick up the king, which is great. If I pick up the whole stack, at least the 2 is on top. That's good, right? And the 3 is on top for this, yeah. So we just gotta figure out why the Y is not working. Yeah. We are passing the card index. That shouldn't really matter. All that matters is the Y. Alright, let's do a refresh. Let's say on, mouse down. We'll put the breakpoint here. Let's try to grab this whole pile here. Okay. We got the 5 of spades, 3 of spades. We are grabbing the entire stack. If we look for hand, put a breakpoint here. Let's play. We have all of them. Card index is always -1. Pile, what pile am I looking at here? I should just be looking at this, not pile. Okay. Alright, I should not pick up the 3. Okay, I guess I was low enough. I should only pick up the 8. And now I should pick up the ace 9. Now I'll pick up the whole thing. Alright, that's one aspect. I think we need to keep track of the pile that this also came from. So on mouse down, we need to say state.hand.pile equals r.pile state.hand.index equals, we'll call pile index equals r.pile index. We'll create a type, export type pile is this. And then use it here as well. Go back to Solitaire, see what errors we have created. This will be pile index. This pile. What is in my hand? My hand is in my hand. Let's just say that. Do the same thing here. And the index is pile index. Just to help guide us in putting the cards back when we drop them. Cool. Alright, so we are able to pick up piles now. So one thing that we need to do is if we click this lower one, it grabs the whole pile, but I should only grab that lower queen. Same thing here, if I just click this 10, I might grab that jack. And that's just because the intersection is happening before the intersection is happening for all of them. And actually, I don't even know if I can get it to work. Let's see. How many logs do I get? I removed the logs, didn't I? Alright. How many? do I get? I get 1. That's because the state is being updated. Once the state is updated, it instantly moves. And the event of the first click is happening for the event of the last clicked. Right now we just need the event of the top thing to happen rather than the event of the last. And this is kind of why you want state to be immutable. So I could add a little bit of more logic here to make sure that I'm actually clicking on the card that I want to be clicking on. Rather than making the engine more complicated to detect this first click, because I feel like there's potential for there to be bugs in the engine if we process events in one order and process drawing in a different order. So pretty much what I'm thinking is we should detect if you're clicking within the peaking region of the card, unless it's the front card. So basically, let's say like const pile equals not stock. Do I need this? No. So I can get rid of these. We have the pile. So here we want to do extra collision detection. Do I need to do that? Can I just do the question mark? No. So if there's a pile and the card is revealed, we'll say const threshold equals we'll say card index plus 1 equals pile dot length. Say if pile I don't have to do all this complicated question mark logic. So the threshold will help us to determine. So if it's the last card, then the threshold is going to be card height. Otherwise, it's going to be card height times peak. Card peak. And basically, and mouse dot state dot mouse dot location dot y minus. Do we need bounds again? I think we do. This dot bounds dot top is less than threshold. What's that equal to? All right. Fine, we'll do a bounds. Drawable. Go to this drawable and say bounds is bounds. I'll just say rect, I think. Rect. Get rect. Export interface. Rect. X. Y. Width. Right. And then for this one, we'll say bounds. Or rect. And then in the engine, bounds x, y with height. And then we go to the calculus. This dot bounds dot x equals dx. This dot bounds y equals dy. It's not this. It's drawable. Drawable. Drawable dot with bounds dot width equals dw. Drawable dot bounds dot height. Yeah, I'm feeling good about the calculus today. And then we need to go to Solitaire and not use top, because why? And hopefully just the 4 gets picked up, even though I'm all the way up here, and it does. And for this one, it should be the 8 and not the king, and it does. For this one, we should pick up everything, and we do. Okay. Just a little bit of extra collision detection. Not too bad. But the alternative code would have been much worse. Much worse. So. We can now pick puck up piles. Does this one also only pick up one? Nice. Nice and nice. Okay, cool, cool, cool. I'm happy with that. I'm hopeful. Okay, so next we want to let's assess real quick. Maybe we should make a list. We want to return cards to the pile. This next. We want to be able to put alternating to drop alternating colors. We want to be able to drop foundation. We could do a timer. I don't know how scoring works, and so I guess I could learn that. Return the cards to the pile, drop alternating colors. Oh, we also, when we do this, we need to reveal top cards. Is that really all there is to Solitaire? Don't you get like 4? You don't? Okay. I thought you got more free cards up here, but I guess not. Alright. So what I'm thinking is we need to create like a giant drop zone that when it triggers, it returns cards to the pile they came from. And we need it to be the last thing. So const drop zone drawable. X is 0, Y is 0. Width is width, height is height. And what I'm going to do is we're not going to need this green background anymore because we're going to have this green background. And then we're going to add it to the drawables. Drop zone. I need to declare the state of Solitaire state. I need to do I need to draw the drops. JK, the green is not gonna be here because order of operations. So this one wants an on mouse up, which does not exist. So we'll go to types, we'll go to on mouse down, highlight this, capital key, capital X, save it, up. We will go to the engine and see if we have an on mouse up. We do. We're going to take the code from on mouse down, put it in on mouse up. Event. CID mouse up. Go to it. Go to here. Excuse me. Copy it, paste it. CID mouse up. Signal up. What the heck? Mouse up signal. Nice. We don't need the index. Back to types. Actually, it should be state, return state. Go to the engine, find on mouse down. I feel like all of these have this requirement. We should probably just do this. Just saving some code. Oh, I should have taken the ampersand. Delete. D. TD. P. Okay. Clean. Mouse up. On mouse up. Up. Okay, back to the solitaire. So basically the idea is if we get to this mouse up event, that means we didn't drop, and we still have cards in our hand, that means we didn't drop the cards onto a valid drop zone. All right, let's go back to this is revealed. Let's go back to this state where things were hidden. And we can't pick this up, right? Can't pick them up anymore, but we can pick this up. And so the idea would be if I was actually able to put this somewhere, it would reveal this top card automatically. But we can't yet. All right, so what are we gonna do instead? We're gonna go to here. I'm gonna say const pile equals state sub state dot hand dot pile and what did I do for the other thing? What did I call it? Okay, cool. If state dot hand dot pile is not equal to hand and state dot hand dot pile is not equal to error, then we will do this. And we will do state dot hand dot pile index. And then we will dot push state dot hand dot cards dot splice from 0 onwards. I'm gonna just spread this. Okay. So hopefully it picked this up. When I drop it, it goes back. The 3, what will work? Queen should be able to go in the king. So we need to be able to add some detection for this. Okay, so let's commit again. Cards, I guess failed drops. Now return to pile. Okay, we're nearing the end of the stream. I have about an hour left, but I'll probably end a little early. Turn the cards to pile, we did it. And so now dropping alternating colors. How do we do that? I think we gotta look at the top card of your hand and the bottom card of the pile. And it's gonna be an event that happens on every single card. One mouse up. State. Return state. It's gonna be a lot of this code. Except we do care. We care a little bit. What do we care about? That's the question. There's also the edge case in which there is no card in the pile. We will figure that out later. Because you should be able to take a king off of a pile and put it onto an empty pile. But I have little to no interest in solving that problem at this exact moment. But I will put it here. Okay, and then back to on mouse down. Not this one. sorry. Not this one. Okay, so this is the pile that we're trying to drop into. So what we want to do is say const keep these together. Const get color something true, red, black. I don't know yet. I don't know what I'm passing in. And that's fine. That's totally fine. Const 2, I will say file dot at -1 const from equals state dot hand dot card sub 0. So we want to put a card state. Solitaire dot card state. And in this we'll say state dot suit. We'll say dot includes. Let's take a look here. Interesting. We'll say, what do we have? Red, hearts, diamonds. All right, back down to here. We're gonna see if we can put it, if we could put the cards that we have in our hand to the pile that we're targeting. So from, let's just say if to and let's do them both for now. There are some restrictions here. We can't place cards. It's not stock. We can't put cards into the stock. So it's important. We should check to see if we're putting it to we should say if card.pile equals foundation, then there's one logic. Card.pile equals tableau, then there's another logic. Right. I think we also want the hand state.hand.cards.length equals 1 for this one. Otherwise we just don't go down it. So we'll focus on dropping opposite colors. So we'll see if get color up to is not equal to get color up from, then we can do the thing. You know what I'm thinking is at this point we should probably be trying to figure out how to opt out, because the code for putting is going to look very similar, so I don't want to write it twice. So if it's 1, then we return state. We try to avoid doing anything. If they're not equal, if they are equal in this case, then we return state. We could change all of this to be equals, or return state. We change this, return state. Just trying to opt out. Oh, if not 2 or not 1, return state. This is probably the only if else if I'll allow for now, unless I see a way around doing multiple statements. So for this one, if the length is not equal to 1, then we won't allow it. What else? If 2.suit is not equal to from.suit, then we'll return state. We won't do it. If 2.rank is not equal to from.rank, then actually we need to do a subtraction. If the hand, we're taking the hand, we want the hand to be 1 bigger. So let's actually do this. If it's not equal to 1, then return state. We want the thing coming from our hand to the pile to be 1 bigger than the thing we're putting it to. Okay, and then in a similar fashion, we want the thing coming from our hand to be -1. We want it to be smaller. If it's not, then we return state. I think in all other cases, now I know this, we don't actually handle putting to empty piles at the moment, but This is a good start. All right, what am I doing? We're gonna say pile dot push dot state dot hand dot cards dot splice, all of them. Okay, time to test it. So hopefully I can drop this on the floor. I can't, perfect. Let's try to figure out why. Go to sources, find foundation, or let's see where we opt out. So we'll take the 3. Interesting. Something happened. This is where we're going. All right, let me refresh. All right, so the queen can go on this king. So we're not opting out, we didn't opt out. Oh, we're opting out. Oh, why isn't there a card in my hand? I feel like we should not have hit drop zone first. We shouldn't have. Or maybe we did. Slug drop zone. Interesting. Oh, because we changed the draw order. That's gotta be last, dead last. Okay. Alright. Now we have something. Hey, let's go. So we should be able to put the king here. We'll figure that out next. Well, I can take that up, I can take this up. I can't take this up. The A should be able to go here at some point. 7, 5, ace, 4, should be able to go here. Right. Alright, so what I'll do is whenever I move a card in this way, I'll say state. State.hand.cards. For each card dot does that even work? How am I so unlucky? Alright, let's go. Worked. Alright, and then this should reveal. Cool. Time is it? 4:20. 4:23. Okay. So we could drop alternating colors. So we'll do the add commit. We can now drop on alternating colors. Excellent, beautiful. Top tier. On mouse up. So now we're going to reveal the top card of each pile. So I'm going to do state.tableau.for each. We'll just say pile. And we'll say const top equals pile dot at -1 if top dot reveal equals true. Why can't you just give me something good? I don't know. It doesn't really help much. I need a red. Am I ever gonna be able to do it? Alright, here we go. Nice. I almost feel like there should be like 2 different states. There should be like the state that you're rendering and the state that you're creating, because we're actually changing the state mid-render. I think that given that we calculated bounding boxes, we probably should do things in a different order. But we've solved this. Reveal top cards, done. We can now drop reveal top cards of Tableau. Nice. Alright, what else are we doing? Drop onto the foundation and dropping onto Tableau. I think after that it's pretty much all the features you could expect from Solitaire, at least MVP for Solitaire. And our engine held up pretty nice. We didn't need to manipulate it too much. We just had to add the Z. But we might change how events are processed. Because I don't know if you can notice this in the lag, but if I click this, there's like a lag between the 10 and the 9. That's no good. And that's because the 10 uses the state before the 9 uses the state, I guess, in order to figure out where it's being drawn. Which is a little surprising because I would have thought the 9 would be drawn later. You would draw 9 later and therefore, I don't know. Well, we could find out. It would allow us to remove the extra intersection code. That would be nice. Yeah, Zuha, there's potential for that. The problem is our state is mutable right now. Usually for libraries like that, the state needs to be immutable, meaning that what that means exactly is we're actually changing data structures in the heap storage rather than on the stack. Or creating new memory and changing that new memory instead. So we're not truly doing things correctly yet, but like just for the purposes of getting it done fast, I'm not really too concerned about that. But like in this case, we're actually having like 2 state steps in a single draw cycle. And so the draw states are being desynced. Yeah, let me think. So there's reasons. Generally speaking, when something is on the heap, you have a reference to it. Right, so maybe I could do like an Excalibur draw. So there's heap. And then there's stack. So typically when we're talking about heap memory, any kind of memory can be in the heap. But typically when you make something in the heap, it kind of stays around a little bit longer than stack. So stack memory, the way the stack memory works, every time you call a function, for example, you're going to create another stack. And then another function call will create another stack. Another function call will create another stack. And so in theory, depending on scope, this function might be able to access this function's data, this function might be able to access this function's data, this function might be able to access this function's data, depending on scope. You know, if they're all different scopes, then yeah, they can't do that. But regardless of that, each of these functions will have its own memory. And as the functions get resolved, that memory gets deleted. It goes away. So for example, like in one of these more complex functions, this draw function, it creates all these variables and puts all these variables into its stack memory for the most part. into the stack memory. But once this function is completely over, and all of its 10, 20 variables that I've created will end up getting popped off of the stack, and this is the only memory that we have left now. Which brings us to heap. Why do we need heap? The heap kind of gives us the ability to keep memory around for longer, because the heap is not necessarily tied to a stack memory. And so traditionally what you might do is you might create memory in this stack that is a reference to something on the heap. And so that memory gets stored in the heap. And so you might say like, I don't know, some big data structure gets stored into the heap. And let's say that's this job. The job of this function is to create that big data structure. Well, there's no way for this to return that data structure, because if you create it on the stack, once this function finishes, it deletes its own stack and that data structure is gone. And so the heap is a nice way to be able to like pass the data around from object to object, or from function to function. Because what this would actually return is a pointer to that data. And so this might create some reference to something onto the stack. And when the function finishes, it actually returns that data to this stack. And now this has a reference to the data on the heap. The data on the heap survived. Now the only thing that in theory got deleted from this is just like an integer pointing to the address. And so like maybe, 4 bytes of memory was deleted. And it just gave that 4 bytes of memory essentially over to this stack. And so to me, like heap stack is like longer lasting memory, shared memory. And you usually do it so that there's a few reasons. One would be it's cheaper to pass the data around, because the alternative is something called a struct. A struct would make deep copies of objects. And so like if you had this giant data structure as a struct and you returned it to this parent function call, you would make a deep copy of every single property of that struct, then pass that up. And then let's say that this needed to pass it up, it would make a deep copy of everything, pass that up. And every time you're using this object, you're taking deep copies and passing it around. And if you have a lot of properties, it's going to be very expensive. And so that's another reason to use heap. The heap makes it so you could just create this pointer to something and just easily pass around like this integer that's pointing to it from stack to stack. And you don't need to worry about creating clones and copying all the fields and all that really heavy processing. You just pass around this tiny number from stack to stack. Anyway, I hope that's clear. If you have specific questions, you feel free to ask. That's at a high level. So which one you say you generally use for state management? Well, in the world of JavaScript, you kind of don't have a choice of what to use. Pretty much, like any object you make in JavaScript is going to be on the heap. You have no choice. Whereas like in a language like C++ or C, you do have a choice of what's on the heap, what's on the stack. In terms of state management, I would say generally speaking, stack's going to be better because it's harder to manipulate data that you're not supposed to be manipulating. Because if you're passing deep copies all around, if you edit the deep copy, you're not editing the original. If you're doing a heap and then you edit the reference, then you're editing the original too. So if you want to do if you want to make state management as easy as possible, then using stack, but it's still going to be computationally expensive if you have a big state, because you're going to be copying every single property. I mean, that might be, you might consider a motivation for me to use. So for now, I used a number. Well, I could have used a date object. And it's totally fine either way. There's no problem either way. But first things first, dates are hard to serialize. They're hard to convert to a data structure that is you can easily save it to a file and then read it from a file. That's the first thing. The second thing is dates go on the stack, or the, sorry, they don't go on the stack, they go on the heap. And so if something manipulated in one place, it would get manipulated in every place. So there is that risk. But if you have a number, that goes on the stack. You don't have to worry about this being manipulated, it's impossible. But the property now can be. But the number that is stored there, physically stored there, you can't say that the number 1 is number 2. Why do dates go in a heap? It's just because it uses, if you're gonna do a new date, anytime you see the word new means heap storage. And in order to create a date, you're gonna say new date. But a lot of languages have that signal, where if you use new, it's going to be heap memory. JavaScript, you don't even have to say new. If you just do this, that's instantly heap memory. Straight to the heap. And what's stored in A is just a reference to the heap data. The 1, 2, 3, all these are all of these are stack memory. String is also heap, but it's a little bit more complicated. Does the OOP use heap a lot since it uses new a lot? Yeah. It's very heap heavy. And there's, as far as I know at least, 3 ways of managing heap memory, because when you create memory on the heap, you need some way to signal that you're done with that memory. Otherwise that memory, like I said, that memory doesn't just go away. That's why it's so good to be able to pass values from one stack to another, is because that memory stays around for a longer time. It doesn't go away until you tell it to go away. But different languages have different ways of signaling, hey, I'm done with your memory. You can go away now. And so for languages like JavaScript and Java, they have what's called a garbage collection cycle, where pretty much if you have allocated enough memory, JavaScript will suddenly be like, okay, I'm out of memory. It's time for me to free up some memory. And so it goes through all of the data chunks that it has allocated onto the heap and finds out what's being used or not. And then it deletes the things that are no longer used and frees up the memory. And so when you're using Java, JavaScript applications, you might notice you're using it for a little while and then just freezes, hard freezes for 10 seconds. That's the garbage collection happening. There's other languages like Python and I think Ruby, where pretty much every time you use a reference every time you use a variable to be referenced by something, there's like this internal counter that tracks how many times it's been referenced. And every time you stop using that reference, there's an internal counter that also decreases. And pretty much if that number ever gets to 0, that's when it deallocates the memory. So it's as you're using the variable, as you're using the memory, Python is determining, should I delete this now or keep it around? And then there's probably more, but then there's C++, C, where you just call malloc and dealloc to allocate and deallocate memory. Or is it free? I think it's called free. Malloc and free. I don't know how Rust works or Zig works. It's possible they have different ways to manage memory. But the three that I mentioned are the three main ones. Garbage collection, tracking, and managed. What happens if a language deletes something you want to use later? Then there's a bug with the language. That would be a major bug for the language. Like you might see that with potentially early versions of languages, but usually that's like that never happens. There's just so many trackers that are happening at a thread safe level that it shouldn't be a concern. Now, for the two for Java, JavaScript, and garbage collected languages, that should never happen. For languages like Python that have internal counters for each variable reference, it's also not going to be an issue. However, in memory managed programming languages like C and C++, you could totally free up some memory that you're not done with, and then still try to access that memory, try to use that memory, but there's the possibility that another part of your program is not using that memory. And so you're like referencing tainted memory at that point. So yeah, it won't happen in these more the memory is controlled by the languages. If it's memory controlled by you, the user, the programmer, then it's totally possible, and it is a problem. You can run into really big security vulnerabilities by using these memory management languages. Reading data that you shouldn't, even executing things as code that you shouldn't. What did that change? Okay. Yeah, no problem. I hope it helps. Six, 5. Six. I feel like there's an optimal strategy for Solitaire, and I just don't know it. Oof. Oh, that's a 9. Never mind. Let's go. I'm killing it. So this should work. This should work. Yeah. On to Solitaire. And we were able to do this pretty quickly with the engine we built so far. The main mission functionality is like these abilities to drop onto these empty spots. So maybe we do that. Okay, for the tableau, we'll say on mouse up. And then we'll say state. And then we'll return state. And then we'll say, we have the index up there. All right. I'll check it out. I'll probably play it later off stream. And then we can try coding it tomorrow. We do state dot tableau dot subindex dot length if equals 0, and I want to know what's in your hand. Const hand card equals state dot hand sub 0 dot card sub 0. And card dot rank equals king. If all of this is true, then I can put a king into that tableau row. So we say state dot tableau subindex equals state dot tableau subindex equals. We'll do push. Dot push dot state dot and dot cards dot splice sub 0. Okay, let's see. It's gonna take a little bit to set it up, but let's make it happen. There's a 3. Okay. Here's this. There's this. Take the jack. 4 goes on to 5. Nice. We just need a king. Come on. Oh, we got it? Does it work? Oh my gosh, it's not revealed. State.hand.cards.for each card. Card.is revealed equals true. Okay, and then we're going to take similar code for the foundation. Except we will only accept one card at a time. This is going to be ace. And cards dot length equals 0. All right. 6, 5, ace. No. What you mean? Okay, well at least it's doing this. Oh, tableau. What do you mean tableau? It needs to be foundation. Alright, let's see if we can win. 6, 2, ace, No. Is it just not going into this? Yep. It's opting out. What card are we dealing with? Rank 1. What is ace? 1. What's the length? 1. Oh my god, 0. It should be 1. Okay. One more time. I can put this here. Red 10. Nothing. Oh wait, there's a jack. Alright. Huh? Oh, it's gone. Goodbye. Oh no. Oh, I never drew it. I never told it where to go. It should actually be in the error state, yeah. Good card. We're gonna do similar code to the tableau. Except it's gonna be foundation. Foundation. And then we're gonna do plus gap times 1, 2, 3, 4. 4 plus card width times 3. It's not gap, it's padding. Alright, let's play some solitaire. No. I need to change the Y. And then I wonder, it should just be true. The Y should just be padding. It's a little off, just a little bit. Let's see. Padding times 4. 0, 1, 2, 3. It should be 3. 1, 2, 3. I don't know what it should be. Yeah, it should be 3. It should be 3. Okay. Oof, this is a rough one. This does not look like a winner to me. Can I put it here? Hey, let's go. There we go. This is, there's no way this is not a loser. Okay, things are happening. Is it a winner? jinx it. Oh no. I didn't reveal it. We'll find on mouse up. Goes reveal. This one reveals. This does not reveal. df equals, save it. Find the next mouse up. Ooh, this one's complicated. We'll reveal for this one too though. This is the foundation, which reveals. This is the tableau, which reveals. This is the drop zone, which shouldn't reveal. That's for sure. Okay, well, it's not a big deal. It'll get revealed later, I imagine. Hopefully it's not a problem. The next thing I move should reveal all toppers. This should reveal all toppers. Hey, let's go. We're making moves. I'll put the 7 down. Alright. If this game is a loss, I will have to stop. Either way, I have to stop. Is there anything I can move? I can move like 3s and 4s. I just need to put a red king down. That'd be sick. Am I just not seeing something? You know what? Yeah, I'm not seeing this. That was the killer move right there. Yeah, that changes everything. Except I know where to put this 2 now, so I can't save my 3 anymore. Let's just test. Okay, we can't do it. Perfect. Where'd that 3 of hearts go? I thought I had a 3 of hearts. I need a 6. A 6 would be killer. Wait, I had a 3 of diamonds this whole time? Or I had a 4 of diamonds the whole time? Oh, I'm a loser. That's a loser right there. That. Oh. There's no way this one's a winner either. Oh. That didn't reveal. Oh. There's another aspect to revealing. Yeah, this one. I'm gonna create 2 helper functions. Const reveal and state is solitaire.state. Reveal hand. Reveal hand state. Const reveal tableau. State solitaire.state. Take that. Reveal tableau. I feel like we could do both in one, because it's already out of the tableau. So is revealed equals, or is it going to call it reveal? ID reveal. And we say is revealed equals. So in here we're going to do reveal state. Is revealed. Here we'll do C reveal state. What's this? What is this? This is restart. All right. Make sure -m. Make sure we reveal git push. Okay. Yeah, I have to go at this point. Yeah, thanks for everyone hanging out. Alex, I'll check out Superplex later today, and we'll see what we can, what we could do to program for it tomorrow. I'm trying to do like things that add little by little functionality. Superplex, what's it called? Is it Superplex? Superplex might add a lot of new functionality, so we're gonna have to see if we can build games that work up to that, if it seems a little too complex. But it is on my list. Let's do this. We did that, we did that. Nice. But yeah, thanks for joining in, Suha, Alex. Anyone else is here. I'll be back again tomorrow at 10 a.m. Eastern time. But in the meantime, enjoy your day, enjoy your night. I'll see you then. Bye.